This video is a continuation of the first one. Is a continuation of the first part. In first part, we are discussing 1, 2, 3, 4, 5. That is, these 5 are discussing in first part video. Now, the second part video, we are discussing 1, 2, 3, 4, 5. That is the remaining 5 part we are discussing in this second part. So, at first we are discussing the set operation. In the set operation, at first we are giving some important topic and important information about the set operation. In this set operation part, at first we are discussing the union, then we are discussing the intersection, and after that we are discussing the disjoint and difference and complement one by one. So at first we are discussing the union. Suppose this is a universal set U, this is the universal set, and suppose this is the A and B and also C is there. A, B, C is a set. Now, when we are discussing the union, this is the union A, union B, union C. Then all part. This all part is denoted as the union. And another example of union, suppose this is the A and B, two set is there, and this is the universal set U. And then if we discuss A union B, then this all. So in this union sections, element either in one set or two set or common point. Now next part we are discussing the intersection section. In intersection, A and B is a set. Now the intersection part is this one. So this is the intersection A intersection B. A intersection B is marked as this one. Similarly, we can extend this formula more than 2 sets. There is a 3 set, 4 set. This is a universal set, and A, B, C is a 3 set. And now if we discuss A intersection B intersection C, so this is the common point of the set A, B and C. Now this point is the only common part among 3 sets. So this is the intersection of 3, that is the intersection of 3 sets A, B, C. That is A intersection B intersection C is represented this way. Now we are discussing the next part, that is a disjoint set. This is the U. This set is not disjoint because among these 2 sets, this is the common point. So these are the not disjoint set. Disjoint set is this one. This is the disjoint set because there are no common point in the set A and B. So in this section, that is the disjoint sections, we are represent the set in that way, not that way. This is not a disjoint set. This is a disjoint set because A and there are no common point between A and B. Now next part we are discussing, that is a difference. This is the U universal set and this is the A and B. Difference A minus B. So A minus B, this is the A minus B. If we discuss B minus A, and this is the U, B minus A, and this is the A set and this is the B set. Then now next part we are discussing B minus A. B minus A is represent this way, that is we are eliminating the common point of A from B, that is these points are eliminated from B and rest of the point of B is represented by B minus A's. Now we are discussing the next point, that is a complement. Suppose A is a set, then the complement of A, that is the AC or A dash, is represent this all. This all is represent the complement of A and this is a set of A. Now we are completing. Now set operation is completed and now we move to the next part, that is law of set algebra. Now in the section of law of set algebra, at first we are discussing idempotent law. In idempotent law we are discussing that A union B is always A and A intersection A is always A. And the next part, that is a commutative law. Commutative laws gives us A union B is equal to B union A, and similarly A intersection B is equal to B intersection A. And now the next part, that is the associative law. In associative law we are discussing that A union first bracket of B union C is equal to A union B first bracket under the first bracket and then union of C is equal. Similarly, when you discussing about the intersection, that is the A intersection first bracket of B intersection C is equal to A intersection in first bracket intersection of C is equal. Now the fourth, that is the distributive law. In the distributive law we are discussing that A union B intersection C under the first bracket is equal to the A union B in first bracket intersection of A union C. That is union is distributed upon the intersection, that is union, this one union, this is the union, this is the union, this is the union is distributed upon the intersection. Similarly here the intersection is distributed upon the union, that is the A intersection first bracket of B union C is equal to A intersection B first bracket union of A intersection C is equal. Now the last part we are discussing, in the law of set algebra is that De Morgan's law. De Morgan's law gives us that A union B complement, then we get A complement intersection of B complement. Similarly A intersection B complement gives us A complement union of B complement is equal. So this is the complete of law of set algebra. Now we are discussing the next part, that is the duality. Now in the next section, that is the duality sections, we are discussing union and intersection at a times. Union and intersection at a times, then we get A union first bracket of B intersection C is equal to A union B intersection of A union C. These two are first bracket. And similarly, A intersection B first bracket of B union C is equal to A intersection B first bracket union of A intersection C. That is, when we discussing the intersection and the union at a time, these are called the duality of the set. Now we are discussing the next part, that is the ordered pair. Ordered pair means A comma B, that is in the part A comma B. Suppose 2 comma 3, suppose 5 comma 6, suppose 8 comma 9, suppose 9 comma 10, all are in ordered pair. And if we say that A ordered pair B is equal to C ordered pair D, then A is equal to C and B is equal to D. This is compulsory. That is, in ordered pair, if we say any ordered pair is equal to the another ordered pair, then the corresponding element must be equal. So this is the complete of ordered pair section. Now we move to the Cartesian product. Suppose A cross B is the ordered pair of AB such that small a belong from A and small b belong from B. This is called the Cartesian product. Let A is a set 1, 2, 3 and B is a set of 1, 4. Then A cross B is equal to 1, 1, 1, 4, 2, 1, 2, 4, 3, 1, 3, 4. This all. And similarly, if we discuss, then we get 1, 1, 1, 2, 1, 3, 4, 1, 4, 2, 4, 3. So this is the example of Cartesian product A and B and B and A. In general, these two, that is A cross B, is not equal to B cross A. Hope the given information and the example will help you to understand this chapter better. And when you practicing this chapter in later, this video enrich your knowledge about this fact, about this chapter, and help you to understand this chapter better.